Hello guys, welcome to Buxin Code. The problem that we are going to solve today is max level sum in a binary tree. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So let's get started. Here's the problem statement, and it says that you are given a binary tree having positive and negative nodes. Find the maximum sum of a level in a given binary tree. Okay, one example is also given here. Let me explain the example. The example says that we have a tree which is containing 4, 2, -5, then -1, 3, -2 and 6. Now we have to find a level, like I have levels like this. So in these levels we have to find the one which has the maximum sum. So for the first level I have the sum as 4. For the second level I have the sum as 2 minus 5, which is -3. After that, for this level we have sum as 6. Now out of all this I'm going to give the maximum as my output. So 6 is going to be my output. So this is something which is going to be my answer, and this is what we have to do in this problem. Like all the levels, we have to return the maximum sum. I hope you guys got the clear understanding of the problem statement, and let me just now move to the solution. Okay, so before solving the problem, I'm going to write the same example again. So example was 4, 2 minus 5 and -1, 3, -2 and 6. In this tree, we have the levels like the first level, second level and the third level. So what we are going to do is we are going to find the level of like the level sum of each level. So suppose that for any level sum is a variable which is denoting the sum of current levels. So I will write that it represents the sum of current level. Now I am going to maximize this sum. So in order to maximize this sum, I have to store the maximum sum somewhere in a variable. So let's call it a variable which is going to be my max sum. So I will write max sum. Initially it is going to have int min value. After that, what I'm going to do is I'm going to write an expression here which is going to maximize my level sum for each level. The statement is max sum equals to maximum of the max sum that I already have and the current level sum. So this is how we are going to maximize our level sum, and each time we just have to find the level sum of current level, and then I'm just going to use this statement. Let's see how to get the sum of each level. This is the question that comes to my mind after looking at this intuition. So how to get the sum, how to get the sum of each level. In order to get the sum of each level, we use something which is a very popular approach, and this is level order traversal. Level order traversal is similar to the breadth first search in a graph, and what it does is it traverses the whole tree in a level wise manner. So first it is going to traverse this level, after that it is going to traverse this level, after that it is going to traverse this level. But how it is going to do so? So we use a data structure in this level of the traversal. So let me draw the tree quickly. I have 4, I have 2, I have -5, this is +2. Let me erase it. I'm going to write 2. After that I'm going to write -1, 3, -2 and 6. Now for this tree I'm going to have a queue data structure. So I have a queue here. Queue data structure, if you don't know about this, so it is a data structure which allows us to perform operation like this, which is LIFO, or which is FIFO. FIFO operation. FIFO operation says that first in, first out. Okay, so like if I put an element A in this queue, after that I put B, after that I put C, so you can see that I'm putting from the back side, and when I will pop the element or I will retrieve the element, so I will get this a first, because this was the one which get in first. So first in first out, this is what this says. So first I will get a, after that I will get b, after that I will get c. So how we are going to use this data structure here? What we are going to do is, first of all, we are going to add this root in this queue. So I will add 4. After that, for the size of queue that I have, I will retrieve all the nodes out. So first I will get, after that, for this 4, I'm going to, okay, so this is the first level. So I'm going to add this data to my first level. So I will have level sum as 4. After that, I check the childs of I check the children of this node. So the children are 2 and minus 5. So I'm going to add 2 and minus 5 in this queue, and now I don't have 4. After that, I'm done with the first level. So now I have these two values for my second level. So for the second level, I'm going to retrieve out these two values. So, and level sum was 4 for first level. Okay, just write this. After that, I'm going to calculate the level sum for, like, first I will retrieve 2. Why I will get 2? Because this was the first which get in first. So first we put left child, after that we put right child. Okay, so now what we are going to do is, we will get this 4 and I will make my level sum as 2. I will get this 2 and I will make my level sum as 2. After that, I will add minus 1 and 3 in my queue data structure. So minus 1 and 3 comes from here because these are the children of this particular node. After that, I will get this for minus 5. So when I get this minus 5, then my sum will become minus 3, because 2 minus 5 is minus 3. And I will add these two children in my queue. So my queue will have minus 2 and 6. Let me write this clearly. So now for the current, my queue is having only these values, like it is having minus 1, 3, minus 2 and 6. And if you notice, we are traversing each level. No, we are traversing the tree actually level by level. So first we are done with this, we are done with this. Now we are having this level already stored in the queue. So we are going to traverse this level, and we will have level sum as, first we will get minus 1. So level sum will become minus 1. And for this minus 1, there are no child possible. So nothing will be added to queue. After that, I will get this 3. So for this 3, I'm going to add it. So it will become 2. And after that, what I'm going to do is, after that, I'm going to get this minus 2, and for this 3 we don't have any child, so we are again not going to add anything. Similarly, for this minus 2, we'll get this minus 2 and it will become 0, and there is nothing to add, so remove this as well. After that, we have last element, which is 6. For this 6, what we are going to do is, we are going to add first of all to this, so it will become 6. And now there is nothing to add, so my queue is something which is empty. So this is the point where we need to stop. So now what we are going to do is, we have the level sum for each level and we are just going to maximize them. We have to maximize them at each level. I mean, for each level, when I get the level sum, then we have to write this particular statement which says that maximum sum is the max of maximum sum and current level sum. Now if I write the pseudo code, so I will have a queue. So make a queue. After that, q dot add root. This is what we have done. So first add root element. After that, while my queue is not empty, while not queue is empty, this is what we have seen here. When our queue become empty, then there is nothing to perform, then we are simply going to exit out of loop. So what we are going to do is, first of all, we will check what is the size of queue. So size equals to queue size, isn't it? After that, whatever is the queue size, like for this, at a particular point when we were having only like 2 and minus 5 in the queue, then the size was 2. So what we are going to do is, we are first going to store this size, and then we are simply going to traverse, like for I equals to 0 to size, we are going to pop out every node. So get node. After that, add to level sum. This is the first step. This the second step says that add to level sum, and the third step says that get node, add level sum, and add child to add children to a queue. So this is how we are simply going to perform the BFS, and at last we will have the level sum. So we are just going to write the max sum equals to max of the max sum and the level sum. Simple. Now I'm just going to show you the code. I hope you guys are clear with what I have written here and what I have explained at this point. Now I'm going to show you the code. So this is the code, and you can see the code is in C++ and Java, in both language. And now what I'm going to do is I'm going to explain the code. So this is the point. This is how we create a queue in Java language, and we are going to add the root in the queue. After that, I'm initializing my maximum sum as integer.min value, and this is how I'm going to perform the level sum. So the current level sum I have explained. The current level sum I have declared as 0, and after that, while traversing the level, I'm calculating the current sum as you can see here, and we are checking whether my left child is null or not. So if it is not null, then we are not going to add it, else we are going to add the first left child. After that, we are going to add right child. When we are done this is with this level, then we will surely have the maximum sum. So after that, we are just going to maximize this maximum sum, and at the end we are going to return it. So this is the code, and let me just quickly copy this code and let's check whether it works or not. So I'm simply going to copy this code, and after that I'm going to move to my screen. So this is the problem in Geeks for Geeks, and I'm even going to provide the link in the description box. Let's check whether it works or not. Okay, so it's working, and now let me do the same for the C++ code as well. So I'm going to copy this code, and after that I'm going to paste it here. Just now submit it. Okay, let's see whether it works or not. So it's also working. This is all about this problem. I hope you guys like the solution. If you like the solution, then hit the like button. Thank you.